wave. Wave is a kind of disturbance. You see, wave always refers to fluctuating nature. If some person has a variable mentality, in that case, it is normally used that he is a wavy person or he is a person of wavy nature. Wave is not a physical quantity. Wave is a kind of disturbance that transfers the energy and momentum from one place to another. Suppose you are standing near a pond, you take a stick in your hand and just go on stirring the water, you'll find that wave have started traveling in all the directions on the water surface. So wave is nothing but a kind of disturbance. The most important thing, suppose you have a string tied at both the ends and simply you go and put one jerk on the part of the string, you will notice the waves produced in the string. You simply put a dot on that string, black dot or blue dot, you will notice that that dot also goes up and down, but that's not going to travel horizontally. It simply means that in this method, energy has been transferred, velocity has been transferred, momentum has been transferred, but the material is not getting transferred. So, one thing is clear, if the wave is mechanical, it will require a medium, only then these things are possible. A particle getting oscillated, that means the mechanical wave requires a medium. And the wave which doesn't require the medium, it's not our scope right now, but these waves are called non-mechanical. More theoretically, we call them electromagnetic wave. Now, mechanical wave are also classified in two parts depending on the nature of oscillation of the particle taking place in the medium. Suppose the wave is producing horizontally this way, this is the velocity of the wave, and the particles are oscillating vertically, then you would call it as transverse wave. Transverse wave means the velocity and the displacement of the particle both are perpendicular to each other. These kind of waves are represented by this sine wave, in which the maximum displacement point would be known as crest and the minimum displacement points will be known as trough. The distance between two successive crests or trough will be known as wavelength. In transverse wave, you see, the medium must be rigid, and rigidity is just impossible in gases. To certain extent, you can notice the rigidity on the surface of the liquid. That's why it is said that transverse wave could propagate only in solids and on the surface of the liquid. Now, longitudinal waves will have the displacement of the particle parallel to the velocity itself. They are in transverse wave, they were perpendicular, and here we find the displacement of the particle and velocity of the wave both along the same direction. So the particles will oscillate this way. They are oscillating horizontally and they are proceeding as well in horizontal direction. That thing could be replaced by, see, compression, rarefaction, compression, rarefaction, and this process will continue. Compression means that particles have come closer to each other, and rarefaction means they have gone further from each other. The distance between two successive compression would be known as wavelength. Similarly, the distance between two successive rarefaction will be known as wavelength. Longitudinal waves do not have any special requirement, only the medium is sufficient. If there is medium, the possibility of travel of longitudinal wave is quite possible. And sound is a longitudinal wave. That means sound could travel in any medium, that is solid, liquid or gas, whereas transverse waves could travel only in the medium with rigidity, and that is possible in solids and surface of the liquids only. Overall, now we are in a position to say that all the mechanical waves would require elasticity and inertia for their propagation. These are the two essential characteristics of any medium that will require extremely for the propagation of these waves. we have covered all the relevant points for the waves.